Today's maths show is aimed at May the 14th is the GCSE paper 1, which is a non-calculator paper. So that means you are not allowed to use a calculator. So the questions that I have got today, how I'm going to be teaching you is how to use your brain and the knowledge that you have got to do really, really well with your first paper 1 on May the 14th. Usually the paper will start about 9:30, but it just depends on the school. So I've been talking to some of the markers. So some of the people who are going to be marking the GCSE paper, the examiners, this summer, I've had a little conference with some of them, and I've just gleaned some information that might be useful and helpful for when you do your GCSE. Obviously, I don't know what the questions are, and obviously no one is allowed to know. So I'm not going through questions, but what I am going to give you is some advice that will make you approaching and completing your paper with a lot more confidence and a lot more knowledge. My first question is a decimal multiplication question. And I personally have seen some year 11s get this question horribly wrong, and they're not too sure with how to multiply a decimal number by another decimal number. In other words, they can line up the decimal point, but when it comes to doing the multiplication, they're not too sure where to put the digits. And that can really give the wrong answer, the wrong number for the wrong answer. So I'm going to give you a strategy. I'm going to give you a method. I'm going to give you a way of being a lot more confident and then producing the correct answer. Now, remember, with the non-calculator paper, you've got to show your evidence. You've got to show how you arrived at your answer. So 9.67 multiplied by 8.3. So the question is 9.87 multiplied by 8.3. Now, if you do not like setting out your multiplication decimal numbers in a column, here is the best way of addressing and answering the question. Right, so 9.67, I want to turn into a whole number because I'm confident when multiplying with whole numbers. So with 9.67, what do I multiply 9.67 by to turn it into a whole number? If I multiply 9.67 by 10, I get 96.7. That's not a whole number. If I multiply 96.7 by 10, I get 967. So now I've got the whole number. So I've multiplied 9.67 by 100 to get 967. Let's turn our attention to the 8.3. So I'm going to multiply 8.3 by 10 to turn it into 83. So now I have got two whole numbers, 967 multiplied by 83. So I can set it out as a column 3 by 2 digit multiplication question. Now, here's how this can help you. Remember, I multiplied my first decimal number by 100, and I multiplied my second decimal number by 10. 100 multiplied by 10 is 1,000. So whatever answer I get when I do 967 multiplied by 83, whatever the result of that multiplication is, I need to make it 1,000 times smaller. So the digits will need to move to the right, okay? Because it's dividing. When we're dividing, the digits move to the right. Okay, so I have already multiplied 967 times 83. And I got an answer of 80261. 80,261. Now, that is not the correct answer, okay? Because remember, I inflated, I made 9.67 bigger by timesing it by 100, and I multiplied 8.3 by 10 to make it 83. So that means my answer is 1,000 times too big. Now, at the moment, I said to you, the digits in my answer are 80261. The decimal point comes at the end of the one digit. That's in the ones column. That's where the decimal point is. Now, if you remember, I said that that number, 80261, is 1,000 times too big. So I've got to make it 1,000 times smaller. In the number 1,000, we have got 3 zeros. So that means I'm going to move the digits to the right 3 steps. Now, when I move my digits 3 steps to the right, the decimal point is now after the 0. So my answer is 80.261. That is the correct answer, 80.261. Now look at this, 9.67 times 8.3. If I just look at the digit 9 in the ones column and look at the digit 8 in the ones column, 9 times 8 is 72. So I know that my answer is going to be about 75, 80, 82, that sort of number. And look at the answer that we have just arrived at, 80.261. So the point I'm making here, and this has come from a lot of teachers, past examiners, past people who have written papers for GCSE and so on. When you are answering your questions on the non-calculator paper, check your calculations. Check to make sure that the answer that you have got is a reasonable answer for the calculation. That's the reason why I said 9 times 8 is 72. So I've got an idea of what my answer should look like. It's not going to be 802. That's too big. It's not going to be 8 point something because that's going to be too small. So the decimal point, because I moved the digits to the right, has stopped after the 0, which is 80.261, and that is the correct answer. So year 11s, when you're doing your calculation, and that's a 3-mark question, when you're doing your calculations, be very, very careful about how you answer the question. Check your answer. Remember, there's no calculator, and you've got to move really quickly. So always try and get a sense of what your answer should be. Where should the answer be? The size of the number, the magnitude of the number. Have an idea of what that should be. Brilliant. My next question is 33.32 divided by 1.4. 33.32 divided by 1.4. Notice the way I read out my first number. I said 33.32. I did not say 33.32 because we do not express our decimal numbers like that. We mentioned the individual digits after the decimal point. So that's why I said 33.32 divided by 1.4. Now, the other day, working with some GCSE students, I asked them about the different parts of a division calculation. When we're doing division, short division or long division, we've got 3 parts to the question. We've got the divisor, which is the number that we are going to use to divide into the whole. And that whole number is called the dividend. The result of dividing the divisor into the dividend is called the quotient. Quotient. So the result of dividing 1.4 into 33.32, that is the result, is called the quotient. Now, when we are doing short division, it's always easier to be working with the divisor, which is a whole number. It makes it easier to manipulate and it makes your calculation a lot faster. So here's another strategy, another way of helping you to arrive at your answer with a lot more confidence and a lot more speed. I want to make 1.4 into a whole number. So I'm going to multiply 1.4 by 10, and that's going to give me 14. I am now going to do the same to my 33.32. So whatever I've done to the divisor, I'm doing the same thing to the dividend. So I'm going to multiply 33.32 by 10, and that gives me 333.2. I now feel a lot more confident with dividing 333.2 by 14. Here's another strategy to help you. Because we are now dividing by 14, I am going to write my 14 times table in the margin, because I'm going to be looking at how many lots of 14s can go into particular numbers. So I've got 14, 28, 42, 56, 70, 84, 98, and 112. I've just written the first 8 or 9 multiples of 14 just to help me. So I'm going to set out my division as a short division calculation. So 14 is going to be outside of the bus stop, and 333.2 is going to be on the inside of the bus stop. So remember what I did. I multiplied the 1.4 by 10, and I multiplied the 33.32 by 10. So let's do the calculation. 14 divides into 3 0 times. So the 3 goes next to the other 3. 14 goes into 33 twice. There's a remainder of 5, and that 5 goes into the third 3-digit, and then that goes in 3 times, because we're going to have 53. So when we do the calculation, it is 23.8, which is the correct answer, by the way. It is 23.8. Now, we do not need to change anything, because we multiplied the divisor by 10, and we also multiplied the dividend by 10. So 333.2 divided by 14 is 23.8, and 33.32 divided by 1.4 is also 23.8. This just shows you how amazing mathematics is. It just shows you that when you know these strategies, when you know these methods, these rules, doesn't it make math so much more fun? It makes it easier and it makes it enjoyable. And I've always said, year 11s, we want you to enjoy the challenge of doing your GCSE maths paper 1, 2, and 3. We want you to enjoy it. We want you to look forwards to your paper. And that comes with preparation. And today and next week, I am looking at preparation for you year 11. So you've tuned in today. Make sure you tune in next week as well, because we're going to be having part 2. Here's my next question: prime factorization. And then we're also going to be looking at the highest common factor and the lowest common multiple using a Venn diagram. So prime factors. The words prime factorization, prime factors, they speak for themselves. We're looking at a number, and the number that I'm going to look at today is 132. And what we're trying to find out is what prime numbers can we use to get back to 132. So let me explain what to do. We're looking for the prime factors. We're looking for the factors of 132 that are prime numbers. It's all in those 2 words. A prime number is a number that can only be divided by itself and 1. And our smallest prime number is 2. And 2 is also our only even prime number. And factors of a number are numbers that are smaller than the number or equal to the number that can divide equally into the number. So The technique that we teach you in year 10, year 11, and year 9 is we're going to have like a little tree with branches. So I'm going to write the number 132 at the top. I'm going to have 2 branches, 2 legs coming down from underneath it, one slanting to the left and the other slanting to the right. I'm going to take my first prime number, which is even, which is 2, and I'm going to say to myself, can I divide 132 by 2? Yes, I can, because 132 is an even number. So in my little line that goes towards the left, underneath the 132, I'm going to write the number 2, and then I'm going to say to myself, what do I multiply that 2-digit by to get 132? So using my knowledge, using my intelligence, and that's you there, year 11s, I know that double 66 is 132. So what I'm going to do is I'm going to do 2 times 66, and that gives me 132. Right, now, underneath I'm going to circle the 2 because that is a prime number. It is a prime number. So underneath 66, I'm going to have 2 more branches, 2 more legs, one slanting to the left and one slanting to the right. And I'm going to say to myself, what number can I divide into 66? Can 2 divide into 66? Yes, 2 can divide into 66 because it is an even number. And I'm going to say to myself, what do I need to multiply 2 by to make 66? And the answer is 33. So I've got another 2 underneath that I'm going to draw a circle around because it's a prime number. Now I'm not going to draw a circle around 33, am I? Well, that's what you have to be telling me, because what do we know about 33? So 33 can be divided by 1, it can be divided by 3, and it can be divided by itself. So therefore, it is what we call a composite number. Okay? Right. So as we carry on going down and down, we get to our prime numbers that we were looking for at the beginning. Okay? And to make it easier and quicker, the prime factors of 132 are 2, 2, 3, and 11. Okay? 2, 2, 3, and 11. 2 times 2 is 4. 4 times 3 is 12, and 12 times 11 is 132. So I know that I'm correct. I'm going to give my answer in index form. So I've got 2 number 2, so I'm going to put 2 squared times 3 times 11. So the prime factors of 132 are 2, 2, 3, and 11. 2 times 2 is 4, 4 times 3 is 12, and 12 times 11, as I'm sure you all know, is 132. Please remember that this is some advice. Follow it, please, year 11s. Do not use commas when you are separating your prime factors. Do not use commas. And also, if you can, give your answer in index form. So 2 bits of advice. Do not use commas to separate the prime factors, and give your answer, if possible, in index form. So I've just given you 2 squared times 3 times 11. Okay, I want to find out the highest common factor and the lowest common multiple of 2 numbers. One of them is 132, and the other one is going to be 120. I've just created the question. I want to find the highest common factor and the lowest common multiple of 132 and 11. Now, I'm going to use a Venn diagram to help me manage my numbers to get the answer. So I've got my 2 circles, and they join together, they intersect in the middle. Now, I'm going to give you the prime factors of 120 only because of time. But as a year 11 student, you will be able to agree with me and work out the prime factors of 120 are 2 times 2 times 2 times 3 times 5. Let's just check. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 5 is 120. So I've just checked to make sure that I've got the prime factors of 120. Now, using my Venn diagram, I've got the prime factors of 120. I've got the prime factors of 132. So what numbers will go in the middle? Right, so 132 has got a 2, and 120 has also got a 2. So I'm going to put one of those 2's in the middle. 132 has got another 2, and so has 120. So I'm going to put another 2 in the middle because the two 2's are common to both 132 and 120. Now, in the number 120, I have got another 2-digit, but I have not got another 2-digit in the number 132 prime factor list. So therefore, that extra 2 from 120 is going to go in the circle just for 120. And the 3, there's a 3 that's a prime factor of 132, and there's a 3 that is a prime factor of 120. That's also going to go in the middle. So in the middle of my Venn diagram, I've got 2, 2, and 3. To the right of the middle, in the circle for 120, I've got 2, and I've got the 5-digit. And to the left of the middle, I've just got the 11. So I've sorted the prime factors of 132 and 120 into my Venn diagram. Now, very easy. If we want to find out the highest common factor of 132 and 120, all we do is we multiply the numbers that we have got in the intersection, the numbers that we have got in between the two circles. And we've got 2, 2, and 3. 2 times 2 is 4, 4 times 3 is 12. So the highest common factor of 132 and 120 is 12. Now, when we are trying to work out the lowest common multiple of 132 and 120, we multiply everything together that we've got in the whole Venn diagram. So we're going to multiply 11 by 2, by 2, by 3, by 2, and by 5. So when we do that, we get an answer. And we get an answer of 1,320. So 1,320 is the lowest common multiple of 132 and 120. And how did we get our answer? We used a Venn diagram to help us sort and to arrive at the correct answer. Now, do you know what? You know what I'm going to say next? I'm going to say, isn't maths interesting? Isn't it fun? Isn't it amazing? Yes, it is. Yes, it is amazing. Okay? We're going to go for a really, really short ad break. And when we come back after the ad break, I'm going to be looking at quadratic sequences and how we can form a quadratic equation from a quadratic sequence. And I'm hoping there's going to be enough time to look at probability. We did start the show a little bit late because there was a few technical issues, but we're going to maximize the time that we have got available. So don't go too far. See you shortly. Hello and welcome back to part 2 of the maths show with me, Mr. Numbervator, on Chalk Hill Community Radio Station, broadcasting live across the country and even the world. Okay, now a head teacher of a secondary school requested that I teach quadratic sequences. I'm going to actually do a question on the radio this afternoon, because he said that he wanted his pupils and all of the other year 11s to listen to how a quadratic sequence question is answered. So I'm going to be doing the question from the first step all the way through to the final answer. So get your pencils, your pens, your pieces of paper ready. You don't need a calculator, but if you feel that you want to have one by your side, you can do, of course. Now, when I'm teaching this, obviously I'm live on the radio. So you will have to either listen very carefully to what I'm saying, and if you're not too sure about something, send me a quick message, and then I can address your query live on the radio in real time. Remember, the number to use is 07535 644 850. 07535 644 850. So a quadratic sequence. Here we go. I think this is going to be the first time that anyone has had the confidence or the thought to actually teach quadratic sequences on the radio. But why not? Why haven't we done this before? But I'm doing it now. There's no reason why we cannot teach maths on the radio, because we can listen, and maybe you're walking home from school or college or wherever, you're listening to this and you will remember what I am doing. So quadratic sequences. You've all heard of the nth term rule. You've all heard of the nth term, okay? And in year 11, by year 11, you will know how to generate the nth term rule for a sequence of numbers. Right, the quadratic sequence is an extension of the nth term, okay? Now, when we are looking at quadratic equations and the quadratic formula, we use ax squared plus bx plus c equals 0. That's the equation, the formula that we use. Ax squared plus bx plus c is equal to 0. Now, because we are looking at the nth term, we now replace that x with an squared plus bn plus c. An squared plus bn plus c. It's exactly the same thing, but because we're looking at the nth term as the sequence, the x has been replaced with the letter n. That's why it looks and sounds different. So here's my sequence of numbers, okay? Now remember, when we are looking at sequences, the individual numbers are called terms. Yeah, so the first term is the first number, the second term is the second number, the third term is the third number, and so on. So the numbers that I'm going to be using this afternoon, early evening, are 10, 21, 38, 61, and 90. I'm going to repeat those 5 numbers. 10, 21, 38, 61, 90. Now, when you write those 5 numbers down, make sure there's a gap in between each of the numbers. Maybe 6 centimeter gap in between each of the numbers. Don't have them touching or too close together. Right, so what do we do straight? What are we going to do first? Right, first of all, we're going to find our first difference. So we're going to be looking at each of the terms and calculating the difference between each of the 5 terms. And this is what is called the first difference, okay? This is what is called the first difference. So the difference between 10 and 21 is 11. So underneath, in the middle of the numbers 10 and 21, I'm going to write plus 11, because to get from 10 to 21, I'm adding 11. The next first difference is between 21 and 38, and that is plus 17. The next first difference between 38 and 61 is plus 23. And my last first difference between 61 and 90 is 20 plus 29. So my first difference is plus 11, plus 17, plus 23, plus 25. I am now going to look for my second difference from the numbers that I have just read out to you. 11, 17, 23, and 29. So my second difference from between 11 and 17 is 6. My second difference between 17 and 23 is 6. My second difference between 23 and 29 is also 6. So I've got my common second difference. And what we do now is we halve the common second difference. We halve it. We always halve the second difference, and that will give us the first part of our quadratic sequence. That will give us the first part. Now, remember, the second difference was 6. So half of 6 is 3. Remember, I gave to you the quadratic sequence formula, an squared plus bn plus c. So n squared is 3n squared. That is the first part of the quadratic sequence formula that we are putting together. And we're using the sequence of numbers to help us. So the first part is 3n squared. We've got it. That's worth half a mark. Right, now we're going to get the second part of the quadratic that we're looking for. So what we do, I'm going to rewrite my original sequence that I read out to you. So I'm going to rewrite my original sequence, which was 10, 21, 38, 61, and 90. Now, here's what I do, and this is how you can really help yourself and get a lot more confident. Above each of my terms that I've just read out to you, above the number 10, I'm going to write 1, because 1 is that one is telling me the position of number 10 in my sequence. And the position of number 10 is the first. So above number 10, I'm going to write 1. Above 21, I'm going to write 2. It's the second term. Above 38, I'm going to write 3 because it's my third term. Above 61, I'm going to write 4 because it's my fourth term. And above 90, I'm going to write 5 because it's my fifth term. Right. So we've got 10, 21, 38, 61, 90. Above the 10, I've got 1. Above the 21, I've got 2. Above the 38, I've got 3. Above the 61, I've got 4. And above the 90, I have got 5. So these are the terms, okay? First term, second term, third term, fourth term, and fifth term. Right. Remember, we worked out the first part of the equation was 3n squared. We're going to use that now to help us get the second half of the rule for our quadratic sequence. Here's what we're going to do. 3n squared. N is the position of the number in the sequence. So number 10 is the first position. So I'm going to do n squared, which is 1 squared. 1 squared is 1. And I'm going to multiply that by 3. So 3 multiplied by 1 is 3. So I'm going to subtract 3 from my 10 shortly. I'm going to go to my next term, which is 21. That's my second term. 2 squared is 4, and 3 times 4 is 12. So I'm going to be subtracting 12 from 21. 38 is my third term. So I'm going to do 3 times 3, which is 9, and 3 times 9 is 27. So I will be subtracting 27 from 38. I'm going to go to my fourth term, which is 61. I'm going to do 4 times 4, which is 16. and 3 times 16 is 48. So I'm going to be doing 61, take away 48. And then my fifth term is 90. So I'm going to do 5 times 5, which is 25, and 3 times 25 is 75, and I'm going to subtract 75 from 90. So let's do the subtractions. 10 subtract 3 is 7, 21 subtract 12 is 9, 38 subtract 27 is 11, 61 subtract 48 is 13, and 90 subtract 75 is 15. So this linear sequence I've got 7, 9, 11, 13, and 15 is going to help us now to get the second part of our equation. Now, if you notice the second difference, okay, the difference between 7 and 9 is 2. Between 9 and 11, it's 2. Between 11 and 13, it's 2. And between 13 and 15 is also 2. So the second part of my equation is 3n squared plus 2n, because the difference was 2 between 7, 9, 11, 13, and 15. How do we get the last part, which is the number? Well, if you can see that the difference between 7 and 9 is 2, I'm going to say to myself, what do I do to 2 to get to 7? What do I do to 2 to get to 7? And I add 5. So to get from 2 to 7, I add 5. So the last part is plus 5. So my quadratic from the quadratic sequence is 3n squared plus 2n plus 5. And that is the answer. Okay, 3n squared plus 2n plus 5. Now, a lot of people were saying to me, oh, you know, are you sure that you can teach the quadratic sequences on the radio? I've just done it. I have just taught quadratic sequences on the radio. And the reason why I wanted this challenge is because when people doubt it can't be done, I like to prove people wrong. And I'm always proving people wrong. Okay, so I've already had a couple of messages from Year 11 students saying that the one thing that they have got from this part of the question is the first difference and the second difference and what that means, and how you can halve the second difference to get the first part of the quadratic that you're looking for. So if I've been successful with that, that for me is job well done. Okay, now I'm running out of time, and the only reason why I'm running out of time is because we started the show late because there was a slight technical hitch. But when it's live radio, these things happen, and it's good when they happen because we can learn from them. So I have learned from what happened at the beginning how to troubleshoot with a tongue twister there, how to troubleshoot the next time. And I was supported by the radio engineer, and I now know what to do, and I can pass that information on to my fellow presenters should the matter arise. So it's a learning curve, and I've learned from it, and we're never too old to learn. Probability, can you please remember that probability is measured out of 1? Okay, probability is measured out of 1. And so next week, when we come on to our questions, please remember that probability is measured out of 1. It must equal 1. When you are working with fractions, give your answer as a mixed number in its simplest form. Give your answer as a mixed number in its simplest form. How to map and how to get answers when you're looking for a quadratic graph. Please remember that your graph must be smooth. So that means you must not use a ruler. Please do not use a ruler because you want to get that classic smooth U-shaped curve. So no ruler when connecting the quadratic points that you have plotted, okay? Ratio, understand about ratio, and understand the formula for profit, which is change divided by the original. So we're going to do these next week. I'm just running through the end. Remember, when you've got distance is equal to speed and time, speed divided by time, and so on and so on. So speed times time equals distance. Just remember how to convert into miles. Remember about standard form. The number is between 1 and 10. It can be 1, but not 10. And error intervals, we're going to go through simplifying indices, and then working out fractional indices, fractional and negative indices. Please also, just to add to your revision, please make sure that you know 5 different methods for solving quadratic equations. 5 different methods are: 1, using factorizing; 2, using the quadratic formula; 3, completing the square; 4, graphically; and 5, using the calculator. Okay, it's been a great math show, and I've really enjoyed working with you all. I look forward to seeing you all next week. Continue to revise so that you can be the best possible year 11 student you can. Rise above your challenges, rise above everything else. Have a great evening. Parents, families, anyone looking after young people in year 11, give them lots of support and encouragement. If anyone's got a question that you want me to answer, if anyone's got a topic that you want me to cover for next week, because it's part 2 of for year 11s, drop me a message, drop me an email, drop me a message. You know how to get a hold of me, and I will do my best to cover it next week. Thank you very much indeed to everyone listening, and see you all next week, and thank you.